Constructing the kiln. With fire mastered, Akshat's world expanded. He could now cook food, stay warm, and keep the darkness at bay. But as he stared into the heart of his campfire, he began to dream bigger. If he could control and concentrate heat, he could transform the very materials around him, make pottery, purify water, and, eventually, unlock the secrets of glass and metal. To do that, he needed a kiln, a structure that could reach and sustain far higher temperatures than an open fire. He started by observing how his campfire behaved. He noticed that when he built a ring of stones around the flames, the heat was trapped and reflected inward, making the fire burn hotter and longer. He also saw that the wind, when channeled just right, could make the coals glow almost white-hot. Scientific note: principles of a kiln. A kiln is an insulated chamber designed to reach and maintain high temperatures, much higher than a simple campfire. Ancient kilns were made from clay, stone, and earth. Their design traps heat and allows for controlled airflow, which is crucial for processes like firing pottery or smelting metals. The key is insulation, to keep the heat in, and ventilation, to provide enough oxygen for combustion. Akshat scouted the area for materials. He collected flat stones from the riverbank for the base and walls, and dug up sticky, clay-rich soil from a bend in the stream. He shaped the clay into bricks and let them dry in the sun. For insulation, he gathered dry grass and mixed it into the clay, knowing that as the grass burned out during the kiln's first firing, it would leave tiny air pockets, trapping heat and making the walls more effective. He chose a gentle slope for the kiln's location, which would help with drainage and airflow. He dug a shallow pit and lined it with stones, then built up the walls in a circular shape, leaving a small opening at the bottom for feeding in fuel and controlling the flow of air. He packed the gaps between the stones with his claygrass mixture, smoothing it with his hands until it formed a solid, sealed structure. Scientific note: draft and airflow. Kilns rely on a draft, air moving through the structure, to feed the fire and control the temperature. By adjusting the size and position of the air holes, vents, Akshat can make the fire burn hotter or cooler. More oxygen means a hotter fire, but too much can cool it down or make the fuel burn too quickly. To test his kiln, Akshat filled it with sticks and dry wood, then lit a fire inside. He watched as the flames licked up the walls, the heat building until the air shimmered above the opening. Carefully, he added more fuel and adjusted the vents, learning through trial and error how to keep the temperature rising without smothering the fire. When the kiln walls began to glow faintly orange, Akshat knew he had succeeded. The kiln could reach temperatures far beyond what his open campfire could achieve, hot enough, he hoped, to bake clay pots, and one day, to melt sand into glass or extract metals from stone. Scientific note: achievable temperatures. A well-built primitive kiln can reach temperatures of 900 to 1100 degrees Celsius, 1650 to 2000 degrees Fahrenheit, which is sufficient for firing pottery and even for early experiments in glass making and metal smelting. The combination of insulation, fuel, and airflow control is what makes these high temperatures possible. As the fire died down and the kiln cooled, Akshat felt a surge of pride. He had built not just a tool, but a gateway to the next stage of discovery. With his kiln, he could begin to shape the world, not just survive in it.